What's up, guys? Don't forget to hit subscribe and like, share. I'm just kidding. Being at home drives me a little crazy. What we're going to do today is we are going to talk about something a little bit out of order from the way I usually do it. You can tell clearly from what's up on the screen right now. We'll be talking about is muscles. Normally, I actually do these chapters out of order, where we talk about the nervous system first and then come back to muscle, or the nervous system control of muscles first and then come back to this. But I thought since it's been a little while since we've really talked about the nervous system, maybe we'll save that for later. Now, what we're doing here, in theory anyway, is we're going to be talking about really just one small subset of the muscles here, the skeletal muscles. There are, of course, other varieties of muscles, and we'll touch on them at the end of the chapter. But really, these guys, these are the ones that are going to be really most important for us. And so before we really get into them, we need to understand a little bit about the structure, because the structure of a skeletal muscle is what makes it work the way that it works. And one of the things that we're going to think about here is that the skeletal muscle is built basically as a bundle of bundles, and then within the cells themselves, again, we're going to kind of see that repeating bundle of bundles behavior. So starting from the outside then, we take an entire chunk of muscle here. So say this is the gastrocnemius muscle, back of the leg, back to the calf. The whole muscle is represented by this big chunk of stuff here, right? And this big chunk of stuff is a bundle, right, of smaller segments. And this bundle of smaller segments is held together by a layer of connective tissue called, and this is where you're going to really love me, because I'm going to write all this stuff out with my mouse on a pen here. So we'll see how we do with that. But this outer layer of connective tissue here is called the epimysium. Okay, and this epimysium holds together all of these smaller chunks, which are in turn called fascicles. Which comes from the same root word as our old friend, lately our new friend apparently, fascism. And the reason for this same root here is because the Italians, who invented fascism as a political movement, used a symbol of ancient Rome, imperial Rome anyway, as their as their logo, which was a fascis, which was a bundle of sticks. Now, the reason it was a bundle of sticks and why that was a symbol of imperial Rome is because back in the day, it used to be illegal to bring an army into Rome, right? The idea was that because Rome was founded as a republic, blah, 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 didn't want any military dictators, couldn't bring your army in under arms across the river called the Rubicon, which is where crossing the Rubicon as a phrase comes from, as a point of no return, which is what Caesar did when he conquered Rome, became the first, would have become the first emperor, died before that happened, doesn't matter. The bundle of sticks, therefore, was what the emperor's imperial guards carried to protect him. They couldn't carry swords or anything. So the fascis became fascism, also the fascicle, because it's a relationship with a bundle of sticks. Now, these fascicles are also bundles of stuff. In this case, a fascicle is a bundle of cells. In this case, we're going to call these muscle fibers. Okay. The reason I don't just call them cells is because they extend the entire length of the muscle, right? So a muscle fiber runs from point A to point B. So if you're Manute Bol, who was a basketball player who was 7'4" tall, his quadriceps muscles might have been 1 meter long, which means that every muscle cell in that quadriceps muscle was also 1 meter long, which is pretty cool, yes, but also going to be, as we're going to find out later on, intrinsic to the contraction of that muscle fiber. So the fascicle then, because it's a bundle of muscle fibers, also has to be surrounded in a layer of connective tissue. Here, we refer to this as the and I'm not going to write this out again, perimysium, all right? And then the muscle cell, the muscle fiber, is also surrounded by connective tissue. In this case, this is the endomysium. Okay, now within the muscle fiber, you can kind of see here that there are, again, smaller pieces, right? Within each cell, we have a bundle, yet again, of more cylindrical structures. In this case, we refer to these as myo. Right, so myo, mes, mus. Okay, these are all prefixes to do with muscle. Sarco as well. Myo. Fibril. Okay, and a myofibril is yet again a bundle of smaller pieces, okay, which are these little guys right here. Right, so you can see hopefully these little blue lines, these little orange or red lines, right, and dots here in the end. Those are myofilaments. This is riveting, I'm sure. Myofilaments. So again, bundles of bundles of bundles of bundles. This is how a skeletal muscle is put together. We go back to our myofibril here, okay, we see that in addition to these tubular myofibrils, we also have, let me put my pointer up here, we also have other chunks of tissue, okay? So we see here kind of surrounding and coating, sitting on it like a blanket, maybe is a better way to think about it, is this structure here. This is called the Sarcoplasmic Reticulum. If you remember the endoplasmic reticulum, which in a normal cell, right, processes either protein or a fat, here the Sarcoplasmic Reticulum is that same tissue, but instead what it does is it stores calcium, and that's going to become really, really important for us later on. The cell membrane here gets a slightly different name. We call this the sarcolemma, okay? For reasons that'll become important, if not interesting, later on. One of those reasons that we can see here that makes it different is that we have these invaginations here that come down and actually cross from one side of the cell to the other and separate out chunks of sarcoplasmic reticulum from other chunks. And these are called T or transverse tubules. And these are just parts of the sarcolemma that come in and cross across the cell. Together, one T tubule and two pieces of sarcoplasmic reticulum form an important structure for us called a triad. Now, this is not the Chinese mafia organization, right? This is just the three parts of this cell here. And again, when we talk about the contraction action, this is going to be a big part of that. Okay, so let's take a closer look here at the myofibrils themselves, right? We can see, according to this cartoon anyway, that it's divided out into several sections and zones, okay? And those sections and zones are defined by the overlap of the myofilaments within it, right? So here we've got these blue myofilaments and these orange myofilaments. These are the thin filaments here in blue, and these are made of a protein, primarily actin, okay? But there's also going to be troponin and tropomyosin that become important for us later on. All right, so thin filaments, and then we've got thick filaments, which are made almost entirely out of a protein called myosin. And they are arranged such that they overlap, right? They partially overlap, they interfinger is maybe another way to describe it. And beyond kind of that relationship, they're also set up such that every thick filament here in this orange color, right, is surrounded by 6 thin filaments. Okay, now they don't have to be 6 separate thin filaments, they can be 6 shared thin filaments, but they're surrounded by them. And that on the thick filament itself, we've got these big blobs, right, of myosin, called myosin heads, that reach out towards, you can see it here on the cartoon as well, that reach out towards each one of those 6 thin filaments surrounding it. And these are going to be important for us because these are actually going to be what are involved in the shortening or the contraction of the muscle. They're going to form what we call cross bridges. Okay? But we'll get into all that stuff in a little bit. The zones and bands here, therefore, right, have everything to do with how much light passes through or not, right, on a microscope slide. Okay, so we'll start here with the arrangement of the thin filaments. These thin filaments all come off of a central ring. So there's one here, there's one there, okay, also made of actin. Right? And this central ring is called a Z disc. Okay, and coming off in either direction from the Z disc, coming this way, right, and also going this way, are our thin filaments. So where we have just thin filaments, right, so the Z disc, just the thin filaments, a lot of light is going to pass through here, right? There's not a lot of material in the way. And so on a slide, it shows up very bright, right? So we refer to this as the A band. Now these thin filaments aren't just floating off into space, they're reaching out towards a central structure here. And the central structure here is called the M line or middle line. It comes from German here, Mittelscheibe, okay, which literally just means middle line. And this M line, right, so just like we had a Z disc here for our thin filaments, the M line serves as a starting point for our thick filaments. And they reach out from this M line towards the Z disc on either side, right? And so the thick filaments reach out towards the Z disc, the thin filaments reach out towards the M line, and there's going to be a point at which these two overlap, right, on either side of the M line. From here, from the overlap on one side to the overlap on the other, this is an area where not a lot of light passes through, right, again on our slide. So it's darker. And so this is the A band, right? Now in the middle of this A band, there is a zone where there are only thick filaments, right? So it's a little bit less stuff in the way. It's a little bit brighter on a slide. And so we refer to this as the H zone, okay? H here from heller, which is German for bright. So we have a H zone right smack dab in the middle where it's just thick filaments. It's a little bit brighter. It's not bright, but it's a little bit brighter than the rest of the A band. Okay, so when we look at a slide, right, these are the things that we see. Now, in terms of functional units, right, we've also got a definable chunk here, and that's the sarcomere, right? And when a muscle shortens, it's actually all of the little sarcomeres, rather, that are stuck end to end to end to end to end in a myofibril that actually get shorter, right? And they get shorter by pulling the Z discs closer together, right? They get pulled towards the M line on either side. And so the sarcomere, from Z disc to Z disc, is the functional unit of the myofibril. Okay, so we'll call it good there for this particular video. We'll come back, we'll spend a little bit of time thinking about how we actually make this stuff work, and from there we'll move on to other, perhaps more exciting things.